Hi guys, today we want to continue with our transition metals and actually have three more. Here is the first one out of the three. It's about reactions of some of the ions, cations of TM. First, of course, you see here, right, is copper 2 plus. Okay, we look at the reactions, right? Reactions of 1, copper 2 plus. Second one of cobalt 2 plus. Okay, cobalt 2 plus. Third is not mentioned here, but they will ask you on reactions of nickel 2 plus and Mn 2 plus. Basically, the reactions are, of course, one is the aqueous ion, which means that the salt will dissolve in water. Number two, of course, if you add NaOH, normally you add ammonia aqueous, okay, right, in the complex form. Thirdly, they will ask you for concentrated HCl, and fourthly, they will ask you use a oxidizing agent. Okay, why? To convert the +2 to +3, right? You have to use the E0 values to do this kind of calculation. Okay, so I'm just going to go through all the questions for these four cations: copper 2 plus, cobalt 2 plus, nickel 2 plus, and manganese 2 plus. They always ask you for the shapes, the symmetry, and also for the color. Okay, but let's look at the first one, which is for copper. I'm going to go to the first question here. I prepared 93. Right? Okay, 93 here. See, they say, now, when you read the question, it's very important to underline what they want, because CIE will give you the marks because they want it. They will tell you, describe, okay? Describe, sorry. Describe, red color, describe what you see, which means color change. Describe, so underline what you see, means observation. Observation. Always when you read the question, put extra words here. Okay, what happens? Explain, which means that you need to give the equation or the formula. Okay, explain why the color. Dilute aqueous ammonia added to solution of copper 2 plus under excess. Okay, now for 5 marks. 5 marks, because you want to begin with Cu2 plus aqueous. See, Cu2 plus aqueous, which means a solution, which means it will be copper, right? 2 plus aqueous, which means you're going to start with the blue solution, or the pale blue solution, I want to say. Pale blue solution. There must be a solution, right? And blue and pale, of course, this will give you a ClH2O bracket 6, the 6 aqua complex, 2 plus here, which is this color here, okay? So now, of course, this one here, let's go to the marking scheme so I won't waste time, okay? See? So the first thing is, of course, the pale blue solution. Now, bracket means that they won't give mark, right? You can write it down, but they won't give mark, okay? So now when you add ammonia inside here, ammonia, remember ammonia here, NH3 plus can act, NH3 can act 2 ways. One is acts as a base. Why? Because plus water, it will actually give you it will supply OH minus NH4 plus OH, a small amount. So this fellow here will, of course, react with your copper 2 plus. Okay? You can just put like that, okay? Plus, of course, a 2 OH minus, 2 aqueous here to give you your blue precipitate, okay? Cyanide blue, whatever, okay? CuH2O, sorry, hydroxide. What am I doing? Is HOH. Okay, sorry about this. Right? OH2. So 2 plus 2 minus is your blue PPT. You must say PPT, okay? Right, aqueous and PPT must be explained. Right? So you put here blue PPT. Okay, so observation, right? And explanation. See, 1 mark for each. 1 mark for each. Okay, so now in excess, now actually this fellow here, This fellow here can be written as CuOH2 dot, because actually it's an octahedral complex, H2O 4. Okay, so when you put excess of ammonia, the ammonia will act as a complexing agent. Okay, ammonia here. So ammonia here acts as a what? As a ligand, complexing agent, or act as a ligand now, which means it will displace, it will exchange the O- ligands, H2O water ligands. Okay, excess ammonia. See, excess ammonia. Okay, excess, well, ammonia, NH3, excess. It will kick out all these things and give you Cu, your famous one now. Please, I know they put, see, they put 4 here. Sometimes they put 6 and don't put 6, okay? Because normally it's 4 only, okay? It's a tetra amino, right? 4. This is acceptable, but better still to complete the octahedral. 2 bracket whole thing here, and is, remember here is 2 plus, sorry, 2 plus, okay? Well, remember if you ask for oxidation state, you always sign first plus 2 for copper. Yeah. So up here must be 2 plus, otherwise they put wrong. See, 2 plus. Okay. So there's a difference in this IUPAC system. Explain why is it happen so? Ligand replacement or ligand exchange is a more common word. See? So remember, observation 1 mark, blue solid, explanation 1 mark. Okay, observation 1 mark, explanation 1 mark, and explain why this is so. You can say this one here, of course, is precipitation. Okay? Right? You can explain, but no marks given because it's indeed precipitation. Okay, right. Second one. You do 3 questions for copper. Copper is a very common one. Page 106. I prepare all these things so that easier. 106. Okay. All right, 106 is here. Okay. Now, it's a B part when concentrated HCl, famous question, is added to a solution of copper 2 plus aqueous here. Aqueous here obviously means what? Means Cu, the aqua complex, the hexa aqua. Okay. This is your what color? Pale blue. They just put blue lah. Blue solution there, right? Turns yellow, right? Of course, they tell you, they will tell you that you should know. So a lot of things have to learn by heart. Constant. I'm sorry. What am I doing, man? HCl. Okay. Where got HCl2? This slide is stupid. Okay. All right, this is concentrated. Okay. Of course, you get CuCl4. This is 2 plus, so it's 4 minus here. Okay, 2 minus. This is a yellow color. And it's tetrahedral solution, very important, okay? Turns yellow, the state of formula must be responsible, blah, 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 and version, of course, is yellow color is CuCl4, put a bracket here, 2 minus, and what is it? Ligand exchange. Can be displacement or replacement, but normally exchange is a more popular word because it appears in your syllabus. See, ammonia can act as a base, and ligand. I told you, right? So as a base means what? As a base means ammonia plus water. A base is a proton acceptor, isn't it? Plus water. It accepts the proton from your water to give you NH4 plus. The H plus comes from your water, isn't it? Plus, of course, a base here, right? Okay, so the color change will occur when ammonia is gradually added to a stirring yellow solution, which means, right, until it's excess. Now, remember, ammonia is a stronger ligand. You must know that. Ammonia stronger than Cl. Okay, it means it will kick it out, all right? Okay, so now the thing here of a few colors here. This is 1 mark or 2 marks here. State is 1 mark. Formula is 1 mark. So there's 2 marks here. Here's 5 marks. No, my goodness. 5 marks. Okay. Now there are many explanations here. They say what? Remember here? Describe the color changes. Okay. Right? Gradually added. That means that's little by little. And then they identify the three ions as three ions, okay? Now let's see what the marking scheme tells you. All right. Now, firstly, they say here, okay? Now this is the one mark, okay? Yellow, right? And the type of reaction, ligand displacement, or see now here, blue solution, right? Remember the blue solution is due to aqueous at 1 mark here. See, copper H2O6, right? Sometimes they accept Cu aqueous, but better don't push your fate too far. Okay. Now this one here, remember, now they tell you already it acts as a base. That means as you add slowly, remember now this, we start with this name, right? Okay. Blue. Now as you add ammonia inside, see, let's look at the question again. See, now here. Now, what you do is you got here a solution of what? CuCl4 2 minus. Now, you add into here bit by bit of your ammonia. Okay, right now. Now, when ammonia is added inside there, let's look at this one here. See, when ammonia is, now this is the first one. This is the first thing. Second one. Now, in your solution of copper tetrachloride here, as you add ammonia into solution here, now here's your copper tetrachloride. As you add ammonia inside here, ammonia will react with this fella here that's in here. In here got something and also Cu H2O6 because it's in equilibrium one. These two are present. So ammonia, because it's stronger ligand, so it will react with this fella here to push it to the side here. But you can't see this. You can't see this very much because it's keep on taking here. So as you react with this one here, this thing will shift to the side. See now, right? So the yellow color will disappear, right? You keep on shifting until you get the blue, the pale blue. So here, the solution goes blue or pale blue. So the first thing you observe is it goes pale blue. So what's a pale blue? It isn't fire. See now, because the ammonia react with this fella here to push it to go forward this side here because it's a stronger ligand. So as it goes here, this equilibrium will shift because all of it is yellow green, yellow is here. So you keep on going here. So this yellow color will disappear. And the first thing form is not this one, not this one, it's this one first. The pale blue, okay, which is a copper hexa aqua. Okay. Next, after this is formed, you add ammonia inside. Ammonia also acting as a base, the OH minus. So now the copper 2 plus, right? Copper 2 plus I put here. Copper 2 plus, or you can put copper, excuse me, H2O6 2 plus will plus 2 OH minus from where? From ammonia acting as a base here, okay, to form your precipitate of copper hydroxide. You can put like that, or you can continue to put the water here. It's again an octahedral, plus of course 2 water comes out. Yeah, this is the blue what? PPT, copper hydroxide, remember now? Okay, see, right? So blue PPT because of copper hydroxide. You can put this on here or the whole thing as an octahedral. But this is normally very acceptable. Now, when this is added on to, when you add some more into this solution here, right, for ammonia, excess, ammonia will kick out all these fellows in because stronger ligand than all these fellows here. So the final stage is it will go right into here, okay, to here, to give you your deep blue solution of this fellow here. So the deep blue solution here, you can see, right, is this one here. Now, with or without water, it's still deep blue. With water better. Octahedral, 6 coordination number. Okay, so the mark is given for 5 marks. No, 1 mark for student from blue, due to this one here, 1 mark. Blue PPT 1 mark. Why? Hydroxide 1 mark. Excess, deep blue 1 mark. Why? The copper 2 tetraamine mark. See? Okay. So everything goes step by step. Sometimes this one is neglected. They go straight to here. So it all depends on the marking scheme and the question they ask. Okay. Next one. Sorry. 116. 116. Okay. 116. Okay. Here. Now here is a scheme. A scheme here where it's quite simple here. They ask you for formula and colors, type of reaction, and role of copper metal. Okay, let's go to here. Simple again. See, they put equals here, which means it's copper. You want to put down here in exams, well, you can do so lah. Okay, you know that it's an aqua complex. And put ammonia, few drops. You may know, this acts as a base in it. A base act as a base. Because why? All hydroxides, remember, and carbonates are what? This is solubility laws. Insoluble. You must know this because one year they ask for carbonates, no. Insoluble. Except what? Except PAS, SPS, potassium, ammonium, and sodium. Very simple. Okay, so ammonium is here. Okay, so blue PPT must be your copper hydroxide. Okay, you can put the water if you want. H2O bracket 4. Okay, right? They ask you suggest the formula, which is this one here. Excess, of course, you will kick this bugger. Okay, to form what? The copper, what? Remember, NH4, NH3, tetraamine. Okay, put water. Okay, 2. What charge here? Remember? 2 plus, don't put plus 2. Concentrate here, simple. Okay, this will be CuCl4. No more water because the tetrahedral, isn't it? Right? 2 negative. This is yellow color. Right? Yellow. This is deep blue. You must remember, no, in organic chemistry, there's no chance you cannot, don't remember, you die, you fail. Okay, so we got A, B, C, all the things covered here. Color, solution B, of course, deep blue. C, of course, is what? C, of course, is yellow now. Okay, now we can look at the marking scheme here. Okay, see, A, B, C, right? Copper hydroxide. Yeah. Copper hydroxide, with blue color. Okay, copper hydroxide. Say or put the water inside octagram. Okay. B, of course, is a copper tetraamine. See, with the water there better. See, 2 plus or not plus. Okay, or this one again. Other one. So you see, yeah, your CCl4. All right. Now deep blue, royal blue, whatever water blue, whatever. Okay, good to put solution. Okay, yellow or green. Why was green? Because some of the copper equals 2 plus, which is blue, plus the yellow give you green, but normally yellow would be good. Okay, the last question here they ask you for when you put heated with copper. Okay, that means a CuCl4 2 minus here plus copper. Minus 2 minus plus copper. Right? They say give you CuCl2 minus the point you ask is this a complex ion? Yes. Why? Because the coordination number exceeds the normal covalency. Is this minus here? That means it's copper 1 plus. That means copper here will reduce. These are 2 plus here to copper 1 plus. That means it's a reduction here. That means this is a reducing agent. Okay, itself undergoes oxidation. Okay, so here type of reaction in which C is heated. Well, you can say redox. Okay, you can see redox, but you must explain, no? Okay, deduce a rule of copper metal. That means it acts a what? It acts a reducing agent, right? Reducing agent. See, sometimes it's not just good. Say why redox? Copper Cl4 2 minus, which is here, you can put on top here is plus 2 plus, is reduced to CuCl2 1 minus. This is what? Copper plus 1. Okay, right? Okay, so now let's look at the marking scheme here. Right, see redox. Okay, right, or reduction of copper plus and reducing agent. Okay, who's the reducing agent? Your copper. See now, okay, marking scheme is very clear. Both of them one mark. You don't mark, don't do that. Okay, now we have finished copper. Now let's look at cobalt. Okay, cobalt in 119. Just a few doors down here. Okay, 119. Cobalt. Right, now here, cobalt. Remember always the +2 and the +3 are very common. So they are interchangeable, can be oxidation or reduction. They always ask them here +2, you can go to +3. Okay, so they are very common, these two +2 and +3, you must have this in mind. So copper 2+ ions, okay, shows properties similar to those copper, cobalt, sorry, similar to copper 2+ ions, okay. So similar, it means similar, it means about the same, okay. Information data book suggests formula of copper species form. They want the copper species form, nothing else. Okay, and the type of reactions that take place. Okay, cobalt species, type of reaction. Cobalt 2+ aqueous, of course, this is I put down here already, or you CuH2O bracket 6, what? 2+, okay, plus excess ammonia. Of course, excess ammonia needs to kick up all this water. Now, this fellow here, 6 better okay than 4. They put 4 answers up. Now you must know, you must remember this yellow color. It goes from yellow, accepted is yellow, orange, and brown. All this was accepted. Why? Yellow turn to brown because a copper 2+, a cobalt 2+ become copper 3+, a cobalt 3+ because darker color. Okay, right? So you can see here. Of course, this one with hydroxide can be from NaOH or your ammonia, like your base net, you get your hydroxide. Okay, it's a PPT. Okay, right? PPT. Okay. All right. Now this is actually I think it's blue color. Okay. Right. I can see the marking scheme here. All right. See. All right. Let me put the color blue, red. Okay. First one, of course, cobalt hydroxide. See now. Okay, you can see here, cobalt hydroxide. Wrong one. Sorry. Here. Is it here? No. How come I got it? Here. Sorry. All right. Now, cobalt. Okay, excess. I jumped the gun. Okay, no gun to jump. Okay. So remember, it's always 6 on. 4 acceptable. 4 plus water. 6 better. Okay. Cobalt NH3 6 is a common one. This is what color? Yellow color. Okay, right? Remember cobalt 2+ plus 4 Cl minus. Right? This is blue color. No, cobalt Cl4 2 minus. This is blue color. Be careful. Okay, learn the color. This is pink color. Okay, pink color. Okay, what kind of ligand exchange? Why? Exchange the water, is a cobalt, H2O 6. Take away, kick this out and put in your ammonia. So it's ligand displacement or ligand exchange, 1 mark. Okay, 5 marks. If all correct, you get 5 marks. Right? Plus OH minus, you get your cobalt hydroxide. Okay, which is actually blue and turns red. I think so. Check and see. Precipitation or acid base, right? This is a better one, okay? Right? Remember, OH minus, right? You precipitate just like your copper. Now this one, right? Remember this one is, of course, oxidation. I thought I did it somewhere. No, never mind. Let's go here. Here, see? I told you that cobalt 2+ and 3+ are very common. See, 2+ and 3+. So the point is, in S2O3, this is a very common fellow. I think you better make sure you know. This it's called peroxo disulfate or sulfate. Now it's called persulfate. That's all. This one comes out, of course, in when your homogeneous catalysis. Okay, so cobalt 2 plus normally goes to cobalt 3 plus, not to cobalt. That means it undergoes oxidation. That means this fellow here must act as an oxidizing agent. So you look at your data booklet here, right? This fellow here is very common. So you must look at this guy here. This guy is extremely common use in Form 6, okay? Right? Your persulfate or peroxo disulfate, okay? So yeah, plus electron. That means it acts as, this fellow acts as what? Oxidizing agent, right? Because accept electrons in. A donor electrons is called a reducing agent. Remember, reducing agent, reductant, yeah. Right, see here? Reduction, reducing agent, electron, donor. Okay, and this is how you remember from 5%. Okay, so now you quote this on here, plus 2, 1, I already done here for you already. So now 3 plus to 2 plus, I quote is original E naught, okay? So now remember, it's going from 2 plus, 2, 3 plus, okay? So I reverse it, you can see it's positive, right? So 3 plus is formed, it's a redox reaction, okay? And let's look at the marking scheme, right? See? Cobalt 3 plus or cobalt 3 plus water lah, also can, okay? See, this is better, okay? Because it always equals redox, okay? Right, oxidation or reduction, right? Okay, next one, cobalt 1, 2, 3. I'm just going through all the type of questions you can see other than complexes that comes up. Okay, now here, okay, remember the following scheme shows reaction of the cobalt equals 2 plus, remember 2 plus, right? It's pink color, okay? Pink color. Now this is here your octahedral complex, and see I draw it here already. So with OH minus, of course, give you a precipitate lah, right? Which is your cobalt, what? OH2. Or you want to be the octahedral complex plus your water 4, right? Right? Ask you for a formula, right? Excess, of course, here your cobalt chloride 2 minus. This is, remember, blue color, okay? So blue, they ask you for the color blue. Here. C. Or they ask you B, okay? After you C, okay? This is a pink, right? Now, C, of course, you kick out the water here. Now 6, remember, they prefer 6. Okay, even 4, it's okay lah, but cobalt 6 NH3 and it's yellow color, remember now, okay? I put here 6, 2 plus here. It's pink, of course. Remember? Right? Pink. Solution B. What is this solution B again? Okay, it's blue. COCl4 to minus is blue. See, ask for color. Remember, this is your yellow. So you have to know the colors. Okay? Okay, yeah. All right. See. All right. See the cobalt hydroxide, or you want to put water as you can. See, COCl4 is in. Okay. Now 6, 4. See, they don't accept, here they don't accept 4, no. 6. So I say 6 is the key. Sometimes the marking scheme they give you 4, sometimes they don't. So, well, you better put 6, because 6 is a common one. Okay? Pink. This is COCl4 to minus, this is a blue. See now, this is a CONH3 6 name, right? This is your 2 plus here. Now yellow is a common one. Brown, yellow. Why is brown? Because it cobalt 2 plus go to cobalt 3 plus. Cobalt 3 plus is darker color one. Okay, so they give you the 3 things to choose. Okay, so then cobalt. Okay, finish copper. Now we go 1, 2, 7. One more. 1, 2, 7. Okay, cobalt. Right now here, state the colors you observe when concentrated HCl. Very simple. See, state the colors, they will underline. Okay, concentrated HCl added to aqueous solution of cobalt nitrate. Of course, remember, all nitrates are soluble, so you must know your solubility laws are cobalt nitrate 2. 2 plus goes to, it equals, goes to CO, 2 plus equals, plus of course 2NO3 minus equals. Now this of course is your what? Cobalt H2O bracket, how much? 6. See, you always remember octahedral, 2 plus, which is what color? Pink. Okay. All right. Give formula, geometry, comes from. So it's pink, and you add what? You add concentrated HCl. 5 marks, no. Wow, fantastic, man. Right now, geometry, color, no. Yeah, here. No. To what? You get your cobalt, Cl4, what? 2 minus, and what is this? Tetra. See not? All memory work. Okay, let's get the answer. Is it wrong? No. Here. Okay, starts with pink. No, right? Why pink? Because your copper equals is pink. Wait, doesn't seem to work. Okay. See, pink. Why pink? Because of this fellow here. 1 mark for the color, 1 mark for the compound. You should say, okay, octahedral complex. Octahedral complex, right? Because they ask you for the what? For the symmetry. Okay, right now. Then it turns blue. Why? This one here, blue is 1 mark for this, 1 mark for this. Why is it this one? This complex, right? Tetrahedral. 5 marks, man. So easy, So damn easy, I tell you. Of course, if it's easy, if you know, you don't know, it's damn hard. Okay? So make sure you memorize this kind of thing, okay? You don't go into the exam hall like a gundu and fail, man, I tell you. Okay, 127, I finished. Now let's go to nickel. I've got 2 more to go, then we are done. Nickel, 74. 74. Okay. So down here. 74. Oh, sorry, 94. My eyes are playing tricks on me, man. 94. Okay, go here. All right, properties, blah, blah, blah. Here, when ammonia, this one came out twice, no? When ammonia is added to a solution of green solution, of course, a nickel. It's good if you can draw it out. Okay, here got nickel. Yeah, I had 2 plus, right? Equals, of course, it will contain what? Nickel, water, 6, bracket, 2 plus, okay? You add what? Okay, ammonia. Remember, ammonia here equals can act as a base as well as a complexing agent or a ligand supplier. A gray-green PPT, of course, is hydroxide, right? Which means your ammonia is acting as a base plus water. It accepts. Base means a proton acceptor to give you ammonium ion plus OH minus ion. So this OH minus is the one that will play. Okay, which means the nickel 2 plus here will plus 2 OH minus to give you your gray-green PPT. You must know that PPT, of course, is hydroxide. All hydroxides and carbons are insoluble. You don't know when you die. Just to let you know. Okay, you can put the water here if you want to make octahedral complex. Okay. This is a green PPT. Okay, this PPT dissolve in excess. Of course, you put here excess of ammonia, it will be a now ammonia acts as a ligand, a complexing agent. What is this? A ligand exchange to give you a blue violet. Now it's not in the syllabus, my friend, but it's the same as a copper. So here, of course, the nickel. Okay. Now here, 4 or 6, they should give you correct because they didn't teach you. Okay. Right. Now, let's put this as 4. Actually, 6 is better. Easier to write. 2 plus. This is what? Blue violet. Okay. Blue violet solution. Okay. They say explanation, observation, reasoning, including equations. So you must have an equation, which means this the first one here. Second one, of course, is something nickel, right? Nickel H2O 6. The second equation, First one is this one here, 1. Okay. 2 plus here, plus 6 NH3 gives you nickel. So you want equation means the equations, you give the further equations. You don't be an idiot and then you think you're damn smart. 6. Okay, balance the whole thing. 2 plus your 6 water here. Now let's say you got 4 marks here, beautiful 4 marks here. What do they want of you? Okay, here we are. All right, see now. All right, now nickel hydroxide. Remember the green color is in it, right? The green PPT is in it. Yeah, it's okay. 1 mark. Okay, or you put water there as you can. Now 6 now, right? 6. Right, common one. But they say, or any of this, it means N can be anything. Can be 1, 2, NH3 can be 1, 2, 3, 4, 5, anything. See here, anything. N can be anything. They don't care because we don't do the chemistry of nickel, what? See, no? So they are quite fair, but normally it's 6, okay? Right? So 1 mark here, 1 mark here. Equation marks, right? Now here, of course, you can put this on here without the water, or you can put the water. See, no? Okay, it's on here, or whatever, as long as you, but I'm warning you to can, right? But this is the most common, this one most common lah. Okay, don't do the so obtuse one, okay? So now nickel hydroxide plus excess ammonia acid, okay? Right, 2 plus 6, yeah, 6. Right, normally 6, so they want all 6, okay? Plus one here, give you, kick out the OH minus, right now, and give you this one here. Right, you put the water here, they should not be wrong, because here it's got the water as well. Okay, so 4 marks, beautiful marks. Right, so now we have done with nickel. One last time before we end today's exciting class. 118 for manganese. Okay, for manganese, here we are. Oh, it's cobalt. Oh, got one more cobalt. Oh, a bidding. Oh, we went through this already. Sorry, 118, 119. I jumped the gun. Okay, here, manganese. Manganese ions plus 2, here plus 2 again. Okay, remember plus 2 and 2 plus and 3 plus, okay, are the common things over your whole period of TM. Have shown similar properties of copper 2 plus ion. Use this information and data booklet to suggest the formula manganese species, the formula, each of okay, reaction and type of reactions, type of reaction and species. So obviously, right? NaOH are precipitations here. So simple, right? So it's of course Mn hydroxide. 2. You can put the water here, 1, 2. This of course is precipitation. See, as long as you do more and more past questions, you know what they want, how to write. Of course, we can't say again. Now here, see, if it's same as copper, right now, you got Mn, because we didn't learn the word what Cl4. What does it want? 2 minus. Okay, what's this called? What? Ligand exchange. Okay, now here is a tricky part. Remember Mn2 plus, this fella here, how many peroxide can act as a what? Can act as a 1, a reducing agent. You must know, or an oxidizing agent. An oxidizing agent. But you must know this. I explained already in my keynote. Okay, I show you now. Right here, you better know. I tell you, you're not gonna die. See, H2O2 appear in this side here. That means accept electrons. That means oxidation. If it appear on this side here, you choose which one you want. This or this. This acts as reducing agent now. It donates electrons. See, both of them are here. So here, because your cobalt 2 plus went to cobalt 3 plus have 2, that means it must act as a oxygen. It means this one here. Okay, so the point is, will they give you a positive delta E or not? Okay, here. Right, so I quote this one here. Manganese 3 plus to 2 plus, 149. You can see here. It's 149. Where is it? Here. 3 plus, 2 plus. Yeah, I quote this first. This reduction, because it's going this side. Okay, and of course, the other one here. So I quote the other one here. So remember, this to go to here is oxidation, and here to here is reduction. It means that I put these 2 down together, and times 2 here, the can blah, 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 and of course, it is positive. Means that feasible. That means I get Mn3 plus. Of course, it's Mn3 plus equals, you want to put, okay, H2O6, 6 here, and 3 plus here, redox reaction. Okay, let's look at the marking scheme. All right, here. See, with hydroxide, you get the hydroxide here, precipitation. Let me put this, okay. Okay, or you want to put the water, also can. This is, they also can, but because it's 3+, so, because actually the oxides in the air, one, because remember that in your AS, the top part flash color become brown color, easily oxidized. PPT, okay, precipitation. See now, 4 and 6, etc. 4 is a common one because copy, just like the copper, Ligand exchange, okay. Say Mn3 plus to Mn3+. That's what I want. Ligand redox reaction. Okay. So now I finished. No, I'm famous. I finished for you all the types, the 4 that came out so far. They ask you all this OH minus with NaOH, with ammonia aqueous, with constant HCl, with an oxidizing agent. All these things they'll ask you. Okay, type of reaction, right? All these things here. So you have to beware and prepare for yourself. The next one I will teach you hopefully tomorrow will be on color. After color, it will be your catalyst, right? Then no more lah. Okay. Last one, of course, is called your distribution factor. Okay. So let me see. I want to stop.